All right, number 1, we have 4 parts, and that's going to be most of the assignment. We're going to be having 4 parts when we're describing the difference in the graph. So we want to determine the basic function that was used to change this. So look at your power, okay, on x. The biggest power I see is x squared. So they want you to identify first the parent function. And if you have those, you can easily pull them up. So the only one, x squared, that's the quadratic. So this is the basic function that they're looking for. So right here, I'm just going to type x, keypad, and get my square. And then do squared, x squared. That's the basic function that was changed. Then part 2, we want to identify the shape of the function. So you need to know what it looks like. So again, if you refer back here, it shows you the graph of that function, a parabola shape. So that's this graph here. Now there's several of them, so you need to know them. And then part 3, we want to apply what happened. Now this is not written in the way that I really like it, so I'm going to rewrite this so that I can see what's going on. And what I mean is I'm going to write the x out front of this. So this is number 1, and they're using SX. I don't know why they changed the letter so much, but maybe to get you used to that, it doesn't matter. SX equals, and I'm going to do parentheses. I'm going to put that negative x out front because my formula has an x out front. And because it says minus x, that means x is negative. The 2 is positive, so I'm going to do plus 2, and then squared, and then minus 3. So what you need to be doing is comparing what you see to the transformation equation that you were given. And you can see clearly there's a grouping symbol, so I know that this number 2 corresponds to h. I know that this corresponds to k, so I can tell what these are going to do. And then I see that negative in front right here. So that means b is negative, a negative 1. And so I'm going to be looking at what's going to be happening from these 3. I don't have an a value out front. I don't have something being multiplied. So what is going to happen? So you got to follow the order. You start inside and work your way out. Okay. So we're going to shift 2. Remember, it's going to do the opposite of what you think. So that positive 2 is going to go left 2. So we're going to have a left shift of 2 units. Okay, so we do that and it moves. Vertical stretch or compression, we don't have one of those. We don't have that out front. So don't worry about that. There's none. X-axis reflection. Okay, there's not one of those. Okay, because there's nothing out front. So no. Y-axis reflection. Yes, we do, because this is negative. So think about this. If x is negative, so think about it. If you had a positive 5 and then you make it negative, it's going to flip across the y-axis. So when x changes negative, it flips across. So we have a y-axis reflection, and now you see our graph moved over. So it looks like it was reflected, or it looks like it actually moved right 2, when in fact it moved left 2, but the reflection moves it. So this is kind of what I was trying to mention in the overview at the beginning, but it takes care of it for you, so be careful. And then vertical shift up, yes, we had a shift, the 3, but it's negative, so that means we went down. So we went down 3 units. And then that's it. So let's go ahead and do the next one, or there's one more part. We want to know the domain and range. So I believe we've talked about domain and range, but if not, let's look at it. Let's just go back to our parent functions. Let me kind of mention it from here. So in this graphic, they're showing you the domain and range of the quadratic function, or the x squared. Since the domain is all real, there's not any shift that's going to change it. So it's still going to be all real numbers, or negative infinity to positive infinity. So your domain here is not changing. Even though I moved it, I'm still getting all the numbers on the axis. So I'm going to do negative infinity, or let me just do all real numbers. That's the easiest thing to do. They have the boldface R. That symbol means all real numbers. Now, with the range, we actually have to change that. So if you recall what the original range is, it is 0 to infinity. Now, what did we do to our graph vertically? Because of this number, our graph went down. So if we just compare our parent function, which would start in the middle, the horizontal shift is not going to affect the range, but the vertical shift will. So my graph went down 1, 2, 3. So instead of starting at 0, it is now starting at -3. So now my range is from -3 to infinity. I just went down 3. And so you can just kind of use the transformation to help you come up with that, because you can't see the graph any longer. Like once you move, you can't see the graph, but it's nice to be able to do it from the graph. So just be aware that that is coming up, the domain and range, and then we can kind of write it out before we get there from the graph. So I guess I have to use the keypad to do half open, half close interval. So I want close open like this, -3, comma, to positive infinity.